Hello. Good morning to everyone. My name is Sheikh Nagur Mirawali. I am the lecturer in mathematics. Okay, now we will continue the mathematical induction. Before, I have told you two problems which are very important problems for the Board of Intermediate of Telangana and Andhra Pradesh. Now, the third problem is, I have discussing about the third problem, remaining the third problem, that is by the principle of mathematical induction, do that so and so. Okay, so now I will do this one by the mathematical induction. So observe that in this problem, in LHS side of the given statement, there will be not given nth term. First we need to find out the nth term. Observe that here, in each and every term having the numerator and denominator. In numerator it will containing always 1 in each and every term. In denominator, in first term, first term 1 into 4, second term 4 into 7, third term 7 into 10. That means every term in the denominator containing the two products. First we have to consider the first product. So let us take the first product here. The first product 1, 4, 7. Next what will get? 10 and so on. Okay. Is in which progression? Is in AP, where the first term A is equal to 1. Next common difference D is equal to T2 minus T1, that is 4 minus 1 is equal to 3. So now the general term formula Tn is equal to A plus n minus 1 into D. So put the value Tn is equal to A means 1 plus n minus 1 into D means 3. Now substitute in this one 1 plus 3n minus 3, that is 3n plus 1 minus 3 minus 2. So the general term is Tn is equal to 3n minus 2. Okay, this is the nth term of the first product. Next, in the second product 4, 7, 10. Okay, consider this sequence 4, 7, 10. Now 4, 7, 10 and so on is also in AP, where first term A is equal to 4, common difference D is equal to 7 minus 4 is equal to 3. Now the general term Tn is equal to A plus n minus 1 into D. Substitute the values 4 plus n minus 1 into 3, that is 4 plus 3n minus 3. So you will get Tn is equal to how much? Simplifying this one, Tn is equal to 3n plus 4 minus 3 plus 1. So that is. Now we have to consider here. Now let's consider S of n is equal to 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus and so on, plus the last term is also in numerator 1 and denominator we get two products. The first product is this one, second product is this one. We should write 3n minus 2 into 3n plus 1. So this is the LHS side. Now what is the given here RHS side? N by 3n plus 1. This is our first statement. The statement given S of n is equal to this is 1. Now we are going to apply the mathematical induction for this. So for doing the mathematical induction, first case 1, let n is equal to how much? 1. Now LHS you have to consider. How do you take LHS? If n is equal to 1, first you need to consider only the first term. What is that? 1 by 1 into 4. 1 by 1 into 4, that is equal to 1 by 4. Now RHS, so RHS value is this one. This is the RHS value. So now put n is equal to 1 in the RHS side. 1 by 3 into 1 plus 1, that is 1 by 3 plus 1, which is 1 by 4. So we get both LHS and RHS are equal. Then what we say that S of 1 is true. Therefore, S of 1 is true. Okay, next, in second one, case 2. Case 2. What we have taken? Assume that the statement is true for S of k, for k n is equal to k. S of k is true. So that means if you substitute n is equal to k, you will get the 1 by 1 into 4, 1 by 4 into 7, plus 1 by 7 into 10, plus up to and so on. What is the nth term here? 1 by 3n minus 2, 3n plus 1. 1 by 3n minus 2, 3n plus 1 is equal to. So this is the in terms of n. Now we have to write here n is equal to k. Now 3k minus 2 into 3k plus 1 is equal to RHS side value k by 3k plus 1. This is S of k statement. Now we are going to edit the k plus 1th term on both sides. On RHS side, what is the last term? 1 by 3k minus 2. This is the last term. In this term, we have to write k is equal to k plus 1. We will get the k plus 1th term on the RHS side. That term we are going to add on both sides. Okay? Now we are going to add this term. How do you obtain this term? By putting k is equal to k plus 1 on the left hand side of the last term. Okay? That is. Now we are going to add the last term here. Okay? Now we will get this one. Now writing the last term on the RHS side, LHS side, and simplifying the RHS side, the values. Okay, now we will get this one. So on RHS side, k by 3k plus 1, and simplifying this one, 1 by 3k plus 3 minus 2. 3k plus 3 minus 2 means 3k plus 1. 3k plus 3 plus 1 means 3k plus 4. Now, taking common 1 by 3k plus 1 on the RHS side and simplifying. Write down the same value on the LHS side. Now taking common 1 by 3k plus 1 on RHS side. How much you will get? K plus 1 by 3k plus 4. Here we have taken the common 3k plus 1, 3k plus 1. This can be taken common outside. So we will remaining answer will be k plus 1 by 3k plus 4. Writing the LHS side same. Now simplifying here, taking LCM here. That is we get. Now we are going to doing factorizes of 3k square plus 4k plus 1. Now we are taking this one 3k square plus 4k plus 1. So your product of first and last term is 3 into 1, 3. Now taking 1 here. So what is the last sign here? Plus. If you edit this one, how much you will get? 4. Now you will get the 4. That means middle term answer. So the factors are 3 and 1. Okay, they are the factors here. Now put 3k square plus 4k plus 1 in answer. Now we will get that is 1 by 1 into 4 plus 1 by 4 into 7 plus up to and so on. The last term, what is that? last term 1 by 3 into, don't simplify here, we have to simplify only on RHS side. Plus 1 which is equal to, here the final answer, so 1 by 3k plus 1 into what we will get here, factors 3k plus 1 into k plus 1, k plus 1 by 3k plus 4. Now cancelize here 3k plus 1 and 3k plus 1. Now we will get this one. Okay, now we will get this answer. Now finally we have to check whether this statement is true for k plus 1 or not. Okay, now what is the given statement we have considered? Look at here, our final step is this one. This is our final step. This is our given statement. Now observe that put n is equal to k plus 1, we will get our statement. Okay, now we will make this equation in terms of k plus 1. After that we have to observe that the statement. Plus 1. Now already here k plus 1 is there. Now this can be written as 3k plus 3 plus 1. So finally 1 by 1 into 4 plus 1 by 4 into 7 plus up to and so on, 1 by 4 plus 1 minus 2, 3 into k plus 1 plus 1 is equal to k plus 1. We are taking in these two terms 3 common. How much you will get? 3 into k plus 1 plus 1, that is. Now observe that here in the given statement, what we have taken here, the statement is S of n. In S of n statement, in this one, put n is equal to k plus 1, n is equal to k plus 1, we will get our final answer. Okay, this is the final answer. So that means, therefore, the statement is true for k plus 1. S of k plus 1 is true. Finally, what we have to write? Therefore, the statement S of n is true for all n belongs to n by the mathematical induction. Okay. Okay students, now we will go for another problem. Okay student, our next problem is this is. Okay. Observe that here also there will be not given nth term. So we have to find out the nth term. How do you find out the nth term? In the first term, here 2 into 3. Second term 3 into 4. Third term 4 into 5. That means in LHS side every term should contain the two products. So what is the first product here? 2. Here also first 3. Here also first 5. We have to take the 2, 3, 4 sequence here. Now 2, 3, 4 and so on is in automatic progression. So where small a is equal to 2, common difference is equal to t2 minus t1, that is equal to 3 minus 2 is equal to 1. Now the general term tn is equal to a plus n minus 1 into d. So put the values 2 plus n minus 1 into d, that is 2 plus n minus 1, that is n plus 2 minus 1 plus n. So the answer should be Tn is equal to n plus 1. Similarly, we can find for the nth term of 3, 4, 5 second product. Therefore, Tn is equal to n plus 1 plus 1, that is n plus 2 we will get. Okay. By the same process, we have to find out that we have to get Tn is equal to n plus 2. Now, let us consider S of n or statement S of n is equal to, so 2 into 3 plus 3 into 4 plus 4 into 5 plus up to and so on n term. N term means nth term also containing the two products. The first product is n plus 1, second product is n plus 2, that is n plus 1 into n plus 2 is equal to, what will be the RHS side? N into n square plus 6n plus 11 by 3. This is the our given statement on. By using the mathematical induction on it, we have to prove the statement. Now, let us consider case 1. Let n is equal to 1. Now, LHS side. What is the LHS side? So, you have to take only first term. Why? Because of we have considered n is equal to 1. That's why we should take the first term only. That is 6. Otherwise, you can substitute in this answer in the last term on the left hand side. You will get also 6. Okay. Now, RHS side. RHS is equal to, so this is the RHS answer. Put n is equal to 1 in this one. 1 into 1 square means 1. 6 into 1, 6 plus 11 by 3. So finally, 6 plus 1, 7. 7 plus 11, 18 by 3. 3 ones, 3 6 are. So 6 is the answer. Therefore, LHS is equal to RHS. Hence, we have to write the statement is true for n is equal to 1. So 1, 2. Now case 2. What we have to consider? Suppose that the statement is true for n is equal to k. That is, we should write 2 into 3, 3 into 4, plus 4 into 5, plus up to and so on. Put n value k. Now k plus 1 and k plus 2 is equal to k into k square plus 6k plus 11 by 3. This is. Now adding the k plus 1th term. What will be the k plus 1 term? How do you get the k plus 1th term? In this one, you have to write k is equal to k plus 1. You will get the k plus 1 term. That k plus 1 term should be adding on both sides. That is, when you have to substitute k is equal to k plus 1, then you will get this answer. Now adding this term on both sides. Okay, we get this one. Now simplifying on the right hand side, so we get this answer. Now taking LCM on the right hand side, write down the left hand side, same to same. Taking LCM on right hand side, this is we get. Next one, finally 1 by 3 into k cube plus 6k square plus 11k plus 3k square plus 3 5s are 15k, 3 6 are 3k. Simplifying this one again. Okay, and we get this one. Now taking this polynomial, we have to find the factors of this one. Now consider this polynomial k cube plus 9k square plus 26k plus 18. So it can be considered as suppose f of k because of this is in terms of k. So put k is equal to 1 if you get 0, then k is equal to 1 is the root of this one. Now the fact is k minus 1 is k minus 1. So by using the trial and error method, we have to write k is equal to 1, k is equal to minus 1, k is equal to 2, k is equal to minus 2. So if k is equal to 1, we can substitute in this f of k. If f of 1 is equal to 0, then what we say that k minus 1 is equal to 0 is a, k minus 1 is a factor. Okay. Or if it is not equal to 0, then we will go for f of k is equal to minus 1. If f of minus 1 is equal to 0, then what we say that k plus 1 is factor. Okay. Next, observe here, if k is equal to minus 1 in this one, we will get the answer 0. Okay. Otherwise, what is the sum of the odd power coefficients? Odd power coefficient. What are the odd power coefficients? 1 plus 26. That is equal to how much? 27. In the same way, even power coefficients. What are the even power coefficients? 18, 9. How much? This is also 27. Now we can subtract the sum of the odd powers coefficient and sum of the even power coefficients. Now we will get 27 minus 27 is equal to 0. So that is the shortest procedure, whether k is equal to minus 1 is the root or not. Okay. Okay, that is, we get k is equal to minus 1 is a root of f of k is equal to 0. Now k plus 1 is a factor of f of k. So by doing division algorithm theorem, by Horner division method, we have to arrange the descending power of f of k. We should write the only coefficients. So k cube coefficient 1, k square coefficient 9, 26, 18. If there are any term is missing here, for example, k square term is not there in this one, we will write the k square coefficient as 0. Okay. Now, what is the factor of this one? We have the k plus 1 is the factor. That means root is k is equal to minus 1. Now, dividing by this one. First of all, here we can take 0. Now, adding these two ones, 1 plus 0, 1. Now, minus 1 into 1, how much? Minus 1. Now, adding these two ones, how much you will get? 8. Now, again, minus 1 into 8, how much? Minus 8. Now, 26 minus 8, how much? 14. 26 minus 8 plus 18. Again here, minus 1 into 18, minus 18. How much you will get here? 0. Okay, this is we get here. Now, f of k can be written as here. F of k is equal to, this is the f of k answer. The factor of this one is k plus 1. Now, here this is the quotient of the polynomial. What is the quotient? If here one of the factor is k plus 1, that means the degree of this f of k is decreased by 1. Now, this is the k square coefficient, this is k coefficient, this is k power 0 coefficient. Now, this can be written as k square plus 8k plus 18. Now, this can be substituted in the final step. This one we get, okay, we will get the final step is this one. Now, we have to arrange the right hand side of this one. Given, what is the given here? This is our statement. If we put k is equal to here k plus 1, we will get the final answer in terms of k plus 1. Same answer we will get this answer in terms of k plus 1, then we say that the statement is true for k plus 1. So observe that here. So what is the final step here? K into k square plus 6k plus 11. This is we have written k into k square plus 6k plus 11 by 3. Okay. So keep it in mind here. Now we can write same LHS side common is equal to 1 by 3 into your k plus 1. Okay, observe that your k is equal to k plus 1. Already k plus 1 is there. Now we have to arrange this one, k square plus 8k plus 18. Here k square is there, 6k, we want here 6k. Now k square plus 8k can be written as 6k plus 2k. Next, what is the constant you want? Plus 11. So this can be written as plus 11 plus 7. Okay, this is. Now finally on right hand side same into k plus 1 into here we get k square, that means we want k plus 1 whole square. What is the k plus 1 whole square? K square plus 2k plus 1. So we can get k square plus 2k plus 1 on the above step. Here k square plus 2k is already there. What we have want here? Plus 1 is there. Plus 1 means this can be written as 7 can be written as plus 1 plus 6. Now remaining terms, what are they? 6k. Next one, what is that? Remaining answer 11. Now finally LHS side same 1 by 3 into taking k plus 1. Here this is of the form a plus b whole square. Now k plus 1 whole square into, in these two terms taking 6 common, k plus 1 plus 11. Now finally we should write the answer here. Okay, this is the left hand side. Now right hand side can be written as k plus 1 into k plus 1 whole square plus 6 into k plus 1 plus 11 by 13. Okay, sorry, by 3. Observe that in the given statement here k plus 1 is there in the place of n. Then we say that s of k plus 1 is true. S of k plus 1 is true. Therefore, by the mathematical induction, the statement is true. What is our statement we have taken? S of n is true for all n belongs to n. That is, it is the simplification of the question. Okay, dear student, the next problem is this one. In the same process of before problem, we are going to do this one. Okay, now solution. In this problem also does not given the nth term. We have to find out the nth term first of all. So observe that in every problem this is having both numerator and denominator. Numerator and denominator. In the same process, nth term also having the numerator and denominator. First we have to observe that what is the numerator value. Numerator is in the first term 1 cube is there. In second term 1 cube plus 2 cube. In third term 1 cube plus 2 cube plus 3 cube. That means in the same nth term of the numerator we will get 1 cube plus 2 cube plus 3 cube plus and so on plus n cube. That is the numerator of the nth term. What is the numerator of the nth term? Now the nth term of the numerator is 1 cube plus 2 cube plus 3 cube plus up to and so on n cube. So already I have told you This is the sum of the cubes of first n natural numbers. So that means the answer should be n into n plus 1 by 2 whole square. So the answer should be equal to n square n plus 1 whole square by 4. This is the nth numerator of the nth term. Okay. Next, denominator. Observe that in denominator the first term is 1, second term is 1 plus 3, third term is 1 plus 3 plus 5. That means in the denominator of the final term is the sum of the odd natural numbers. First odd natural numbers. That means odd natural numbers means there are n odd natural numbers. So observe that the denominator is 1 plus 3 plus 5 plus up to and so on n terms. That means this progression is in the arithmetic progression, is in AP. They are adding to each other. That means this is the sum of arithmetic progression in AP. So here A is equal to 1. Common difference D is equal to T2 minus T1. That is 3 minus 1 is equal to. Here we are going to find the sum. So every term containing the plus values. That means every term should add to other terms. So that means this is the sum of n terms in the arithmetic progression. The formula is Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula. We can substitute n by 2 into how much? 2 into 1 plus n minus 1 into d means 2. So simplifying this one, n by 2 into 2 plus 2n minus 2. 2n minus 2. So cancelling plus 2 minus 2. We will get n by 2 into 2n. Now n and 2 to cancel. Now the final answer should be n square. Okay. So observe that this value n square is the denominator of the last term. Here this value is the numerator of the last term. Okay. That means nth term. So nth term numerator this is, nth term denominator is this one. So now we can substitute the nth term here. Okay. Now let the statement Sn. S of n means our statement. Now 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3. 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus up to and so on n term. So n term, nth term is this one by this one. That means n square into n plus 1 whole square by 4 whole divided by how much? N square. So that is the LHS side. Now RHS, n by 24 into 2n square plus 9n plus 13. So this is now cancelling n square and n square. How much you will? Okay, you will get this answer. So by using mathematical induction procedure, we should do this one. Okay, case 1. So let n is equal to 1. Now LHS side, LHS equal to 1 2 by 1. That is the first term. That means 1. Now RHS is equal to this one RHS. So 10 is equal to 1 in this one. 1 by 24 into 2 into 1 2, 9 into 1 9 plus 30. So 2 plus 9 11, 11 plus 13 24. That is 1 by 24 into 24. Cancel, you will get the answer 1. Therefore, what we say that both LHS and RHS are equal. Therefore, hence we have to write S of 1 is true. Okay, that is in case 2. Suppose S of k is 2. That means S of k is this one. Now we have to add k plus 1th term on both sides. So that means k plus 1 term means this is k plus 1 whole square by 4 on both sides. Now we are going to add this one. Okay, now we get this one. Okay, now writing. Okay, now simplifying right hand side here, k plus 1 whole square means this one. Now taking the LCM on right hand side, 24 is the LCM here. Now here 6 into k into 2k square plus 9k plus 13 plus only k is there here, k into here we will get 6 here, 6 into k plus 2 whole square. Now write down the same left hand side. Now 2k cube plus 9k square plus 13k plus 6 into a plus b whole square, a square plus 2ab, that means 4k plus b square means 2 square 4 by 24. Now simplifying this one, we will get the same process. We can consider this one is the polynomial in k. So we can factorize this one. Let f of k is equal to 2k cube plus 15k square plus 37k plus 24. So in the same before problem procedure, if k is equal to -1, we have to put here, it will be 0 because of here odd term coefficient, odd power coefficient 2 and 37. How much? 37 plus 2, how much? 39. The same way even power coefficients, that means 15 and 24, how much? 39. So odd term power coefficient summation and even power coefficient summation both are equal. Then we can subtract them, we will get the answer 0. Therefore k is equal to -1 is a one of the root of f of k is equal to 0. Now f of k, that means f of -1, f of -1 is equal to 0. Therefore k plus 1 is a factor of f of k. So now we find out the another factor. Now we will go for this one, taking the descending powers of this one, 2, 15, 37, 24. Now dividing by k is equal to -1, so 0, 2, 1 into 2, -1 into 2, -2, subtracting this one, 15 minus 2, how much? 13, this is -13, we will get the 24. Now 1 into -24, -1 into 24, -24, we will get the answer 0. Now the coefficient is this one. The coefficient, how can you take the coefficient? The dividend is the k cube, starting with the degree 3. So if we get the one of the factor is k plus 1, now the degree will start from k square, after that k, after that constant. So therefore now f of k can be written as k plus 1 into, what is the quotient here? 2k square plus 13k plus 24. This is the f of k. Now we will put the f of k answer in this equation. Now substitute the values in this one, we will get k plus 1 into, the factor is this one, 2k square plus 13k plus 24 by how much? 24. Now in the same procedure, we finally the given sum, the right hand side is n by 24 into 2n square plus 13 9n plus 13. This is the given right hand side. Now we will convert this one in terms of k plus 1 answer. So that is equal to, here k plus 1 is there by 24. Now I have to write here 2k square, same process, 2k square. Now plus, how much you will get here, 9n. So this can be written as 4k plus 9k. Next one, this also written as 13 plus, we get 13 and 9. So that's why we can separate 9k and 13. 13 can be taken here. How much the remaining? 11. Okay. Now, so here a plus 1 by 24 into, now taking here common 2k square plus 4k. Next here 2 plus 13 can be written as 2 plus 11. We will get this one. In this one, k plus 1 by 24, we have taken here 2 common, 2 into k square plus 2k plus 1. Next plus taking 9 common, by doing 9 common here, this can be written as 9k plus 9 plus 3 plus 11. Sorry, 9 plus 2. 9 plus 2 plus 11. So next step, we have to take a common 9 here. So k plus 1 by 24 into 2 into, this is of the form a plus b whole square, plus we are taking 9 common, k plus 1. Next 2 plus 11, how much you will get? 13. So our final answer is this one, is equal to k plus 1 by 24 into 2 into k plus 1 whole square plus 9 into k plus 1 plus 13. So observe here, in the given sum we have n is equal to k plus 1. So that's why what we say that the statement is true for k plus 1, that is s of k plus 1 is true by principle of mathematical induction. The statement that is s of n is true for all n belongs to n. That okay. Okay, in the same procedure I have given some problems. Please do them. Okay, dear student, I have to give these problems as practice problems. Observe that in the first problem, so here a plus d, a plus 2b and so on. Already you know that this is in the arithmetic progression. Here the nth term should be, what is the nth term? A plus n minus 1 into d. This is the hint for the nth term. Okay, next in the second problem, here this is ar square, ar square and so on n term. This is in the geometric progression. Already I have told you, this is of the form geometric progression. Then Tn is equal to a into r power n minus 1. This is the nth term. In this problem, observe here, every term having the product of two terms. So here this one contain only one term. So this can be written as 1 into 2. Now the first product is 1, 3, 4. You can observe that 1, 3, 4. This is the first this is the sum of, this is the arithmetic progression in AP. In the same process, we can use the nth term formula a plus n minus 1 into d. A means 1 plus n minus 1 into d means common difference 3 minus 1 is equal to, that is equal to 2n plus 1 minus 2. How much? Plus 1. This is the nth term of the first product. The second term here 2 some mistake will be done here. I have to correct this.